Good day, everyone. I am Chantal Noel Victoria F. Chua, leader of the Choco Butternut Group, and today we will be discussing our case study of the manufacturing process of reinforced steel bars used in structural buildings. The first step in the process is to inspect the raw materials from three main sources. First are the iron cast taken from the suppliers. Next are the metal scraps from junkyards. And last are the rejects of the laboratory tests from the previous process. The workers are all prone to the hazards of the metal scraps, which is classified as safety. As a precaution, they are required to wear gloves and goggles to avoid being punctured or wounded by the metals. Once the metals are properly sorted, they will be brought to the induction furnace, where they will be melted together by using electromagnetic induction or heat-producing coils. This furnace will then produce a liquid, unrefined metal where it still has impurities. The workers are exposed to heat radiated by the equipment, metal scraps as it is placed into the furnace, and improper clothing. These are classified as physical and safety hazards. As a precaution, they are required to wear heat-resistant clothing, safety goggles, and safety gloves. This is where the ladle refining furnace will be used. To remove the active impurities of the liquid metal, it will be subjected to a vacuum container, which will be heated at a high temperature of 1570 degrees Celsius to allow silicon, hydrogen, and oxygen to resurface. The workers are exposed to heat radiated by the equipment, metal scraps as it is placed into the furnace, and improper clothing. These are classified as physical and safety hazards. As a precaution, they are required to wear heat-resistant clothing, safety goggles, and safety gloves. Since the furnace only removes active impurities, it will be placed back to treatment to remove sulfur and phosphorus, which will be done in the
I
next
am
process.
Roslyn Antipalataw and I'm going to discuss about the treatment, casting, cooling process of steel bar. The sulfurization. It is a chemical process for the removal of sulfur from a material. This involves either the removal of sulfur from a molecule or the removal of sulfur compounds from a mixture. Sulfur affects both internal and surface quality of steel. Next is dephosphorization. It is a very important metallurgical technique in steel making process to produce high quality steels. It is also the removal of phosphorus from a metal during smelting. The hazard in treatment process are heat radiated by the equipment, refined liquid steel, lime, sulfur, phosphorus oxide, calcium fluoride, and etc. The classification are physical, safety, and chemical. The mitigation measures PPE thermally conditioned clothing, PPE flame resistant clothing, and PPE gas mask. After treatment process, next is the casting process, where the liquid steel poured into a mold which contains a hollow cavity of the desired shape, and then allowed to solidify. The hazard in this process are heat radiated by the equipment, liquid steel, and casted metal high temperature. And the classification are physical and safety. The mitigation measures PPE thermally conditioned clothing, PPE flame resistant clothing, and insulated cast container. Next process is the cooling tower. Cryogenic hardening is a process where the material is cooled to approximately negative 185 degree, usually using liquid nitrogen. It can have a profound effect on the mechanical properties of certain steels, provided their compositions and prior heat treatment are such that they retain some austenite at room temperature. The hazard in these are electrocution and nitrogen, while the classification are physical and chemical. The mitigation measure: properly insulated electrical wiring and PPE gas masks.
The output from the previous process will now undergo the process of reheating furnace. This process will require the use of coal and will emit substances such as coal ashes, sulfur oxides, nitrogen oxides, carbon monoxides, PCDD or PCDF, or polychlorinated dibenzodioxins or simply dioxins. The hazards that this process produces are heat radiated by the equipment, metal scraps, and coal burning emissions. Reheating furnaces are used in hot rolling mills to heat the steel to temperatures of around 1200 degrees Celsius, which is suitable for plastic deformation of steel and hence for rolling in the mill. The heating process in a reheating furnace is a continuous process where the steel stock is charged at the furnace entrance, heated in the furnace, and discharged at the furnace exit. Heat is transferred to the steel stock to it during its traverse through the furnace mainly by means of convection and radiation from the burner gases and the furnace walls. After it undergoes the process of reheating furnace, the output will be liquid steel. The liquid steel will now undergo the process of rolling. It may either go through plain or deformed rolling mill. The hazards that are produced by this process are heat from the rolling mill and liquid metal. Rolling process is one of the most important and widely used industrial metal forming operations. It provides high production and close control of the final product. Rolling of steel is a metal forming process in which steel is passed through a pair of rotating rolls for plastic deformation of the steel. Plastic deformation is caused by the compressive forces applied through the rotating rolls. High compressive stresses are as a result of the friction between the rolls and the steel stock surface. The steel material gets squeezed between the pair of rolls, as a result of which the thickness gets reduced and the length gets increased. As the liquid steel finishes the process of rolling, it will now be produced as plain or deformed steel rods. These steel rods will now undergo the process of cutting. In this process, the rods will be cut into various lengths. From this process, the solid waste such as excess steel will be separated from the products. These products are now called the pre-cut plain or deformed steel rods.
After the pre-cut plane and deformed bars exited the cutting procedure, the curing procedure comes next. The curing process is divided into two parts: annealing and cryogenic cooling.
In annealing, employed to relieve stresses and to increase ductility, heat uniformly, in case of full annealing, to about 75 degrees Fahrenheit above the steel's upper critical temperature and cool in the furnace. Thus, through controlled heating and cooling, specific changes in the properties of steel are achieved.
Cryogenic hardening is a cryogenic treatment process where the material is cooled to approximately minus 185 degrees Celsius, 301 degrees Fahrenheit, usually using liquid nitrogen. It can have a profound effect on the mechanical properties of certain steels, provided their composition and prior heat treatment are such that they retain some austenite at room temperature. It is designed to increase the amount of martensite in the steel's crystal structure, increasing its strength and hardness, sometimes at the cost of toughness.
The end result of the curing process is the cured and cooled steel rods. These were next subjected to several laboratory tests, which are composed of metallographic tests, where the amount of iron and carbon present in the samples were determined; yield strength test, wherein the yield strength against the maximum tensile and compressive stresses that the steel can take in while still being able to return to its original state were determined; tensile strength test, wherein the ultimate strength or the tensile strength of the steel against the maximum force that the steel can withstand before it fractures was determined; and lastly, the flexural bending stress, where the flex or bending properties of the samples were determined.
The rejects that didn't meet the specific standards from any of these tests were returned back to the scrapyard, while the approved ones were delivered to the next step.
Is a process where various steels are classified by their composition and physical properties, while labeling is a process where graded steel rods are being colored based on their grade. In this process, steel rebar products are identifiable through the company logo, which is hot-rolled and embossed onto each bar at specified intervals. The bar size mark, which specifies the nominal diameter of the bar, is also hot-rolled adjacent to the company logo. Mitigation measures, scheduled supervision, and machine guarding. The hazards and its classification. Cluttered workspace is classified as ergonomic. Hydraulic stamper is classified as safety. As the graded and sorted steel rods enter the packaging process, vacuum plastic color-coded based on grade enters the machine, and the excess plastic tabs are considered solid wastes. Mitigation measures, scheduled supervision, and machine guarding. Hazards and classification. Cluttered workspace is classified as ergonomic. Industrial cutters is classified as safety.